You say time flows forward like it's something you could, in principle, catch in a cup. But look at what you actually have access to. You have a wristwatch, a phone clock, a heartbeat, the swing of a pendulum, the decay of an excited atom, a planet going around a star. These are not time. These are physical systems doing physical things. They change, and you use that change as a ruler. You don't observe time the way you observe wind, by watching leaves bend while something invisible pushes them. There is no time pressure you can feel on your skin. No instrument you can build that detects time flowing past it like a current. Here's a small test. Put a glass of water on a table. Stare at it. If time is literally flowing, something should be happening just because the flow is happening. But nothing happens until something changes, until the water evaporates, until the glass cools, until dust settles, until light fades the pigment in a label. You're not watching time. You're watching processes. So what do you mean when you say time passes? Usually you mean your internal record of the world keeps updating. Your brain keeps writing new states over old ones. The room looks slightly different than it did. Your body has moved. The sun is at a new angle. Your coffee is colder. Those are differences between configurations of matter. And then you add a narrative glue. You imagine a conveyor belt underneath reality, carrying one now into the next now. This is wrong in a very specific way. It treats now as a moving spotlight, a special slice of the universe that marches along. But in your direct experience, there is no spotlight. There is only the state you are in, and the traces of other states, memories, photos, fossils, wear marks, recordings embedded in it. If you're honest, you can't point to the flow itself. You can only point to evidence of change and evidence of records. And this matters, because once you stop granting flow for free, you're forced into an uncomfortable question. If time isn't a thing that moves, then forward isn't something you can assume. It's something you have to earn. Take a simple scene, a planet orbiting a star. In your mind, you can run that orbit forward for a year, then reverse the film. The planet retraces the same path. Nothing looks illegal. No alarms go off in your intuition. Gravity doesn't protest. The backward orbit still satisfies the same relationship between distance and pull, the same accelerations, the same curves. That's not a cute trick, it's a clue. Now take something smaller. 2 billiard balls on a frictionless table. One strikes the other, they separate. If you reverse the movie, it still looks like a valid collision, just with the roles swapped. The same kinds of speeds appear, the same angles, the same conservation rules. You can tell which direction you usually see, but the laws themselves are perfectly content either way. This is where your comfortable story starts to wobble, because you've been treating forward as if it's an instruction written into the machinery of reality, like nature has a preference, like it wants things to proceed from cause to effect in a particular direction. But when physicists write down the core rules for motion, how positions change, how forces relate, how fields push and pull, most of those rules don't single out a preferred direction of time. If you take a solution and replace later with earlier, the rewritten history is typically just as lawful as the original. Even with light and electromagnetism, the basic equations don't scream one way. The waves can run outward or inward. The mathematics allows both. You only ever see one of those options in everyday life, waves spreading out from sources, but that only ever is not yet a law. It's an observation about what the world tends to do. Now, there are subtle exceptions. In certain particle processes, nature does show tiny asymmetries under time reversal. They exist and they're real. But they are small, rare, and not remotely the kind of brutal one-way nests you live inside. They don't explain why your coffee cools, but never spontaneously heats itself by stealing thermal energy from the room. They don't explain why you can unscramble equations on paper, but cannot unscramble cream from coffee in a cup. So you're left with a gap. The microscopic rules mostly don't care which way time runs, but your macroscopic world cares obsessively. The world you inhabit is full of one-way transformations, shattering, burning, mixing, aging, forgetting. If the underlying laws don't strongly enforce an arrow, then the arrow you experience can't be assumed to be fundamental. It has to be manufactured out of something else. When you watch an egg fall and break, it feels like you witnessed a law, not a preference, not a tendency, a law. You think the universe has a rule that says, once something is broken, it must stay broken. Once something mixes, it must stay mixed. Once heat spreads out, it must stay spread out. So you quietly imagine an extra ingredient in physics, a kind of one-way pressure, a directional shove, a cosmic no-undo clause. Because if irreversibility were a force, you should be able to point to it. You should be able to isolate it. Measure it the way you measure gravity or electricity. You can't. Instead, take the broken egg scene and strip away the emotion. Replace the egg with something less symbolic, a box divided in half by a removable partition full of gas on the left side and vacuum on the right. You pull the partition out. The gas spreads. It fills the whole box. You call that natural. You call it what must happen. Now imagine the reverse. All the gas molecules, by chance, drift back into the left half, leaving the right half empty again. You say that can't happen. But point to the law that forbids it, not a human law, a physics law. There isn't one. Every molecule in that box is obeying the same mechanical rules in either story. Collisions don't contain a moral preference for spreading out. The walls don't encourage mixing. The equations don't add an extra term that says, thou shalt not reseparate. So why do you feel so certain it won't reverse? Because you're smuggling in a different kind of argument, not impossibility, but humiliation by numbers. When the gas is confined to one half of the box, that's a very particular kind of arrangement. Not special, because it violates physics. Special because it's rare among all the possible microscopic arrangements that still look, to your eyes, like a gas in a box. Once the partition is removed, there are vastly more microscopic ways for the gas to be spread throughout the whole volume than there are ways for it to be all on the left. And the system doesn't need a force to find the common situation. It only needs time to wander. The molecules ricochet, exchange momentum, bounce, and rebounds. The microstate changes constantly. It explores possibilities. And when one class of possibilities outnumbers another class by an absurd ratio, the system will spend essentially all of its life in the larger class, not because it's compelled, but because it would require an astronomically precise coincidence to land in the tiny class again. In other words, irreversible is often just shorthand for we will wait longer than the age of the universe and still not see the reversal. You didn't discover a one-way force, you discovered a one-way bet. At this point you reach for the standard word entropy, and immediately most explanations poison your intuition. They tell you entropy is disorder, as if the universe has an aesthetic preference for mess, as if neatness is fragile and sloppiness is stable. That picture isn't just vague. It's actively misleading because it makes entropy sound psychological, like a judgment made by a human observer. Entropy is not a mood, it's a count. A count of how many microscopic realities can hide underneath the same macroscopic description. Start with something you can visualize without equations, a deck of cards. A perfectly ordered deck aces to kings, suits grouped is one arrangement. A shuffled deck is another. But here's the point, shuffled isn't a single state, it's practically all of them. There are astronomically many ways for a deck to look random enough, and very few ways for it to look perfectly ordered. If you keep doing ordinary shuffles, you drift toward the overwhelmingly large set, not because the cards are compelled by a law of messiness, but because you're sampling from possibilities, and almost all of the possibilities look shuffled. When you say, a cup of coffee with cream mixed in, you're speaking at a coarse level. You're ignoring the exact location and velocity of every molecule. You're compressing an unimaginable amount of microscopic detail into one macroscopic label. Mixed. When you say coffee with a clean white swirl of cream, you're also using a coarse label. But that label corresponds to a much narrower set of microscopic configurations that still look like a swirl rather than uniform beige. Both situations obey the same microscopic laws, but the number of microstates compatible with mixed dwarfs the number compatible with unmixed by ratios so violent that your mind can't hold them. That ratio is the real engine behind irreversibility, not disorder as a moral category. When there are many more ways to be equilibrated than to be structured, a system that is free to evolve will, with near certainty, move into the region of state space with more compatible microstates. It doesn't need instructions. It doesn't need intent. It doesn't need a time arrow baked into the equations. It needs only the fact that it can explore, and that the map of possibilities is lopsided. This is where entropy becomes less like mess and more like geography. Imagine a landscape where almost every direction slopes downward into a vast basin. If you drop a marble anywhere on the rim, it's not that the marble wants the bottom. It's that the bottom is where most paths lead, and once the marble is deep in the basin, there are still paths upward. Nothing forbids them, but they occupy such a tiny fraction of all possible motions that you essentially never see them by accident. Entropy increase is like falling into a region of phase space that is simply bigger. And notice what just happened. We didn't introduce a forward direction of time. We introduced a statement about typicality, what almost always happens when a system starts in a rare, constrained condition and is allowed to wander. The arrow is starting to look less like a commandment and more like a statistical drift. But we still haven't named what forward actually means. We've only described what you tend to see. You're still holding on to a hidden assumption that future is an objective direction like north. That assumption feels so basic that you don't notice you're making it. You talk about the past being fixed and the future being open, as if the universe comes pre-labeled with earlier and later, and you're simply learning the labels. Feynman's move is colder. He doesn't try to rescue your picture of time as a thing that flows. He changes what you mean by forward, he says. When we talk about the direction of time, what we actually mean operationally in the lab, in experience, is the direction in which entropy increases. Not because entropy is a clock, not because entropy causes time, but because the only reliable asymmetry you can build into your description of the world is this. In the direction you call toward the future, systems evolve from less probable macrostates to more probable ones, from fewer compatible microstates to more compatible ones. So forward isn't an extra physical ingredient. It's a name you give to the direction in which certain processes overwhelmingly tend to go. If you don't like that, try to replace it with something else. Define the future as the direction you move. That fails, because you can move either way in space, and your motion is just another physical process inside time, not a definition of time. Define it as the direction clocks tick. But clocks are physical systems. They tick because something inside them changes in a regular way, and those changes themselves sit inside the same one-way pattern: friction, noise, heat loss, relaxation. You're trying to define the arrow using objects that already inherit the arrow. Define it as the direction of causality. But in practice, causality is inferred from records, signals, and correlations, physical traces that are themselves created by irreversible processes. You keep circling back to the same anchor without admitting it. The arrow you actually use is the thermodynamic one. Feynman's answer, then, is almost insulting in its simplicity. If a phenomenon seems to define a direction, we will call that direction the future. It sounds like a word game until you realize what it accomplishes. It dissolves the need for an extra law that says time must run one way. The microscopic laws can remain largely time-symmetric. The macroscopic arrow comes from statistics, and forward becomes the direction from rare toward typical. But this comes with a price that most people try not to pay. Because if the arrow is really about entropy increasing, then the deepest question isn't, why does entropy increase? The deeper question is, why was entropy low in the first place? The gas spreads out because there are more ways to be spread out. Fine. The cream mixes because there are more ways to be mixed. Fine. Heat flows from hot to cold because there are more microstates in which energy is shared out rather than hoarded in one corner. Fine. All of that explains why, given a low entropy situation, it will almost certainly evolve toward higher entropy. But it does not explain why you ever had a low entropy situation to begin with. If you rewind the film of a breaking egg, you are not merely running physics backward, you are demanding that the world begin in an exquisitely arranged, wildly atypical state that just happens to funnel into an egg on a countertop. That's the real asymmetry, not the equations, the boundary conditions. When you ask, why does time flow forward, you are secretly asking why the universe seems to have started in a fantastically special configuration, one that makes entropy increase away from it. It tells you where the arrow is hiding. And once you see that, the flow you thought you felt becomes something else, a gradient, a slope, a one-way drift away from an improbably ordered past. Now the discomfort sharpens. Because the past might not be defined by your memory. Your memory might be defined by the past's entropy. You treat memory as something private, psychological, a movie stored inside your skull. But memory is not exempt from physics. A memory is a physical record. Something in the world that ends up different because something else happened. Ink on paper, a changed synapse in a brain, a dent in a surface, a photon pattern trapped in a photograph. To make a record, You must correlate two systems, the thing being recorded and the medium doing the recording. After the interaction, the medium must carry information about the thing. And for that information to be stable retrievable later, it can't just be a delicate arrangement balanced on a knife edge. It has to be protected against the constant microscopic jostling of the world. Protection has a cost. The cost is dissipation. The act of writing a stable memory is an act of creating additional microscopic clutter somewhere else. Heat dumped into the environment, chemical fuel consumed, metabolic waste produced, photons scattered. A reliable record isn't made by reversibility. It's made by a process that, once it happens, is extraordinarily hard to undo in practice. That is why your arrow of knowledge lines up with a thermodynamic arrow. Not because your consciousness commands it, but because the physical devices that create evidence, brains, cameras, notebooks, fossils, detectors, only work robustly in one direction. Try to imagine a memory of the future, not a prediction. A literal record that tomorrow's event has already imprinted itself into today's matter. To get that, you'd need correlations that run the other way. A present medium that already carries stable, accessible information about a later configuration of the world, without that information having been physically written by an interaction that happened later. It's not forbidden by a slogan. It's blocked by what record means in a world where stable records are built by dissipative processes. This also changes what you mean by cause. In everyday language, the cause is what you can point to with evidence. The broken glass has shards on the floor. The fire has ash and smoke. The crime has fingerprints and surveillance footage. Causes are inferred from traces. But traces are one-way artifacts. They accumulate, they persist, they spread into the environment as radiation, as heat, as altered matter. And that spreading is exactly the kind of process that makes reversal fantastically unlikely. So when you say the past causes the future, you're partly describing physics, but you're also describing the direction in which records can be created and preserved, the direction in which evidence exists. You don't remember yesterday because yesterday is metaphysically special. You remember yesterday because yesterday is the direction in which the world has already paid the thermodynamic cost to leave you proof. If you followed the thread honestly, you end up somewhere that feels almost like a refusal. You asked why time flows forward, and you were told effectively it doesn't flow the way you imagine. What you call forward is the direction in which entropy increases. What you call the past is the direction in which entropy was lower. That sounds like an answer until you ask the one question it cannot dodge. Why was entropy lower? Not why does it increase? Because that part is now almost pedestrian. If you start in a rare macroscopic condition, the system almost certainly wanders into more common ones. The egg breaks because there are more ways to be broken. The gas spreads because there are more ways to fill a box than to huddle in a corner. The record forms because stable correlations require dissipation. Once you accept counting as the hidden engine, the one-way character of ordinary life stops looking like a fundamental rule and starts looking like typical behavior. But none of that explains why the universe ever had a direction to drift. A drift requires a slope. A slope requires a starting point that is not already in the basin. So the real statement behind your experience of time is not, the laws push things forward. It's the universe began in an extraordinarily special condition. A low entropy condition is not just a bit more organized. It is, in the full space of microscopic possibilities, a microscopic target. And yet, everything you call history is built on the fact that the early universe seems to have been like that, ordered in a way that allowed an enormous amount of entropy to be generated later, while still leaving room for stars, chemistry, life, and brains to build records. This is where people often try to patch the discomfort with a cheap story. Maybe it just had to be that way. But had to is exactly what you no longer get to say casually. The microscopic laws by themselves do not demand a special beginning. They allow it, but they don't select it. They are permissive, not directional. So you can treat the low entropy past as a boundary condition, a fact about the universe's initial state, not a consequence of deeper dynamical rules we currently possess. Heat conditions have a strange status in physics. They are not nothing, they determine what actually happens, but they are not explained by the equations that govern evolution once the boundary is given. It's like being handed the rules of chess and then being asked why this particular game began with this particular opening. The rules tell you which moves are allowed from there. They don't tell you why the board was arranged that way at the start. There are ideas, inflationary scenarios, quantum cosmology, proposals about typicality in multiverses, arguments about gravitational entropy behaving differently than the entropy of gases. Some of these are sophisticated. Some of them are speculative. None of them is a clean, universally accepted statement that forces the universe to begin in the special state required for your arrow of time. So the honest ending is not a triumph, it's a boundary. Your experience of time, your certainty that yesterday is fixed and tomorrow is open, rests on something the laws of everyday physics don't fully account for, that there was a direction away from an improbably ordered past. This is where Feynman's answer finishes its quiet demolition. You wanted a mechanism that makes time move. You wanted a river. Instead, you get a landscape, a gradient in the space of possibilities. A world where past and future are not stamped onto reality from outside, but emerge because of how the universe was arranged at one end. And once you see that, the deepest unease is not that the future is unknown. It's that the difference between past and future, so basic that you build your identity on it, may be less like a law and more like a consequence of an initial accident written into the universe's starting condition. Not a flow, a leftover asymmetry, a quiet tilt in the bookkeeping of possibilities that everything else, memory, causation, aging, history, has been sliding down ever since. And it leaves you with a final image that is hard to hold steadily. The arrow of time is not something the universe does. It is something the universe started with. And you are living in the long, irreversible aftermath of that beginning.